Okay, so welcome to another edition of MCube, My Class Maths Matters, and we're going to just look at exponents. The first thing about exponents is that they're all about kind of knowing your rules. Okay, so let's just quickly revise those. When we multiply two numbers with the same base, we add the exponents. When we divide two numbers with the same base, we subtract the exponents. When we raise a power to a power, we multiply the powers. When we've got a product raised to a power, both factors of the product must get the power. Likewise with a quotient, when we've got a fraction raised to a power, both the numerator and the denominator must get that power. Any number with a negative exponent can be put underneath 1 and the exponent can become positive. And then lastly, anything raised to the power of 0 is 1. So let's just do 4 quick examples just using these rules. So here we go with the first one. This one literally requires us to write the answer with positive exponents, which is something that we always want to do. So let's take a look. So the t to the 5 can stay on the top because it already has a positive exponent. What I'm going to bring up to the top is the 3. All right, and I'm also going to bring up the a and write that as a to the power of 5. On the denominator, I'll have 2 to the 2. I'll also have z, and I'll have b. Right, let's just check that we've got all that right. This one's kind of moved down. This one's stayed where it was. This one's moved down and its exponents become positive. This one's moved up to the top. This one's moved up to the top. And this one's stayed at the bottom. Okay, right, let's look at another example. Now this one really just requires that we use our rules to simplify this. Okay, and if we end up with negative exponents, we must change them into positive exponents. So let's take a look. The first thing is that all 3 things in the bracket need to get this power of 3. So the 2 gets cubed, the a squared gets cubed, and remember when a power gets raised to a power, the powers multiply, it becomes a to the 6. The b gets cubed. Right, then we've got times 3a to the negative 3b to the 8. And then on the denominator, let's just leave that as it is for now. That's going to be 24a to the 5, b to the minus 3. So let's just simplify the numerator. We're going to get this 8 over here times 3, which is 24. We're going to get a to the 3 when we add the exponents on the a's. And we're going to get b to the 11. On the denominator, we've also got 24. We've got a to the 5. And we've got b to the minus 3. Right, now at this stage we've got kind of choices. Remember that when we divide, we're going to subtract our exponents. Right, 24 divided by 24 is just 1. We're going to get a to the minus 2. All right, and we're going to get b, 11 minus 3 is actually b to the 14. Right, final answer here, we want it with positive exponents. We're going to go b to the 14 over a squared. Now notice that what we could have done here is we could have pulled these b to the minus 3's up to the top and made them b to the plus 3's, in which case they would have been b to the 14. So you have got choices in terms of things that you can do. As long as you don't break a rule, you'll get the right answer. Okay, then a question like this requires us to first prime factorize all the bases. Right, so we're going to get 2 cubed multiplied by 3 to the power of n plus 1. Right, that's 8 times 3, that's 24. Right, 9 prime factorizes to 3 squared, n plus 1. 27 to 3 cubed. All right, and lastly 8 to 2 cubed, n plus 2. Now you'll see all our exponent rules come into play here. Which of these 2 factors gets the power of n plus 1? Both of them. Right, if there's already a power on a number, we multiply the powers. So this is going to be 2 to the 3n plus 3 times 3 to the n plus 1 times 3 to the 2n plus 2 over 3 to the 3n times 2 to the 3n plus 6. Okay, now on the numerator, we've only got 2 to the 3n plus 3, and on the denominator only 2 to the 3n plus 6. So when I divide those two, I'm going to subtract the powers. I've got 3n plus 3, and from that I'm going to take away all of 3n plus 6. I actually get 2 to the minus 3. On the numerator, I've got 3 to the n plus 2 times 3 to the 2n plus 2. Let's just go slowly here. I'll just do the numerator first. I'm going to get 3 to the 3n plus 3. And on the denominator, I've got 3 to the 3n. Right, now when I divide these, I'm going to subtract the powers. So I'm actually going to end up with 2 to the minus 3 times 3 to the 3. Whatever you do, do not multiply the 2 by the 3 here. You can't multiply them. It's not a normal 2, it's got a power on it. So the last thing that's going to happen here is that we are going to write our answer as 3 cubed over 2 cubed. Right, and we could write that also as 27 over 8. We probably would expect you to do that. Okay, the next type involves simplifying a fraction. Now remember, what you cannot do with fractions, you can't start sort of subtracting pieces. What you've got to do is factorize it in order that you can then divide things out. So there's a common sort of 3 to the n on the top here. And now we're kind of working backwards here. We need to know how our rules work. So in order to get 3 to the n plus 2, I actually need 3 to the 2. Right, remember when we multiply these two things, we're going to add the power and we're going to get that term. Then I just need to multiply the 3 to the n by 5. On the denominator, I've got 3 to the n plus 1. I could write that as 3 to the n times 3 to the 1. I don't have to do it like that, right? I could just sort it out when I do my division. But in fact, now, these two things are kind of, I can divide the top by 3 to the n and the bottom by 3 to the n. On the top, I've got 9 minus 5, which is 4. And on the bottom, I've got 3. Okay. And then the very last one, it's a sort of similar idea, but maybe slightly more complicated. Right, what I'm going to do first here is I'm going to change all of these to prime base of 3. So I get 3 to the 2 into n plus 1, the power of n plus 1 rather. This is minus 3 to the 2n. On the bottom I've got 3 to the 2 and the power is n minus 1. And I've got 3 to the 2n. So I end up with 3 to the 2n plus 2 minus 3 to the 2n, and on the bottom I get 3 to the 2n minus 2 minus 3 to the 2n. Whatever you do, don't start crossing out 3 to the 2n's at this stage, as tempting as it might be. We need to factorize first. So you're going to take out a common factor of 3 to the 2n on both the numerator and the denominator. I'm going to get 3 to the 2 minus 1. And over here, I'm actually going to get 3 to the minus 2 minus 1. Okay, so what's going to happen is I can divide this out, top and bottom. So I actually get 9 minus 1, which is 8. And on the bottom, I'm going to get 3 to the negative 2 minus 1. Now, you could go to a calculator, but let's do it without a calculator. 3 to the negative 2 is actually the same as 1 over 3 squared. So what I've got here is I've actually got 8 over 1/9 minus 1. Now, a 9th minus 1 is actually, if I think of my 1 as 9/9, it's negative 8/9. Right, so now what I've got is I've got a fraction divided by a fraction, remember, or a number divided by a fraction. Remember how I divide fractions? I actually change it over and change to a times. So I actually get 8 times negative 9 over 8. These 8's divide out and I get a final answer of negative 9. Okay, hope you found that useful, and yeah, all the best for your exam.